Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the second lesson on compound angle identities, and in this video I'm going to be taking you through a second example of using compound angle identities to solve an equation. So here we're being asked to solve for 0 to 360 the equation sine theta plus 50 plus 3 sine theta equals 7 cos theta. Now look, what I want you to do is to have a go at this. You've got the skills to solve this without any further instruction from me. Pause the video, think, what can I do with this? And try and work this through yourselves to a solution. And then press play and see if you got it right. That way you're being active in your learning rather than passively watching and writing down and none of it's going in. Make sure you're trying as much as you can to get the most out of these videos that you can, as if it was a proper lesson in school. Right then, I said, what can we do with sine theta plus 50? Well, here we have the identity sine A plus B, which is sine A cos B plus cos A sine B. Now what that means is that I can rewrite this first part of the equation here as sine theta cos 50 plus cos theta sine 50 plus 3 sine theta equals 7 cos theta. And you might be looking at that and thinking, oh okay, well cos 50, sine 50, we could work those out as numbers. Great, don't do that, fight the urge to do that, because you're going to have horrible decimals that's going to make your equation look really messy as you work through it. What we need to think instead is, what do we have and how can we solve an equation? What knowledge do we have to solve an equation with what we've got? Well, we've got sine theta, cos theta, we've got sine theta, cos theta. Can you think of an identity that links sine theta with cos theta? Pause. Hopefully you're thinking, oh yes, sine theta over cos theta is tan theta. Could I use the tan theta identity? Yes, you could. But first of all, what you want to be doing is everything with a sine theta term, you want to be on the left-hand side of your equation. And everything with a cos theta term, you want to be on the right-hand side of the equation. That's only one thing that needs to be changed. So we'd have sine theta cos 50 plus 3 sine theta would equal 7 cos theta minus cos theta sine 50. And because this term here, cos theta sine 50, is a single term, sine 50 is a number, so I have a number of sine 50, I can subtract the whole thing in this way. Now what are we aiming at? We're aiming for sine over cos. So what I need to do is to isolate the sine, isolate the cos. And how do I do that? Well, I can factorise my left-hand side to be sine theta and then bracket cos 50 plus 3. At this stage here, I'm going to put a bracket around the 50 so that later on I don't think that I meant cos 53, because that's totally different. On the right-hand side, I'm going to do a similar thing. Cos theta, bracket, 7 minus sine 50. And it's not as important to bracket the 50 on this side because I'm unlikely to confuse it with the 7, but we'll do it anyway. Now, sine theta over cos theta. So if I divide both sides by cos theta to get to sine theta over cos theta, I would also need to divide both sides by this number here to get 7 minus sine 50 over cos of 50 plus 3. Sine theta over cos theta is tan theta, that's the identity that we're using. 7 minus sine 50 over cos 50 minus 3 is a number. Specifically, what number is it? It's 1.711, and I'm going to use that whole result when I come to do my next step. I have tan theta equals a number. The rest is straightforward. My tan inverse 1.711 to get my principal solution of 59.700. We've done enough cast diagrams now to recall that the second solution for tan is adding on 180. So 180 plus 59.7 is going to be 239.7. So I have two solutions here for theta. I have theta equals 59.7, that's to one decimal place, and 239.7. Similarly, that's to one decimal place. So there we go, key points from this question. We had a compound angle identity with sine that we expanded, and then probably the key bit is realising that we had an equation that contained a combination of sine theta and cos theta. We looked to manipulate it such that you could get sine theta over cos theta and use the tan theta identity to make a simple equation to solve.